So the next thing we need to talk about is quartiles. Quartiles looks a lot like the word quarter, right? And that's kind of a key clue to what quartiles are. So here we have two data sets, one for the big bank and one for the BAS bank, right? We've already found the median, which breaks up our data in half. So it's the 50th percentile, right? But we can also have lower quarter and an upper quarter. So quartiles are values that divide our data distribution into quarters. So this lower quartile, which is the median of the lower half of the data, that's going to be my 25th percentile. And my upper quartile, which is the median of the upper half of data, right? If we pretend only this was our data set, that median value, that middle value, this marks the 75th percentile. So, like I said, but a little more fleshed out, is the lower quartile, or first quarter Q1 is something we also call it, divides the lowest fourth of a data set from the upper 3/4, right? It's the median of the lower half of the data set, and it marks the 25th percentile. So I can talk about it in lots of different ways. I could say Q1, I could say the lowest fourth, I could say the 25th percentile. They all kind of mean the same thing. We also know our middle quartile, that's Q2. It's our median. It marks the 50th percentile. And we have our upper quartile, that's our Q3. It divides the lowest 3/4 of data from a data set from the upper fourth. It's the median of the upper half of a data set, and it marks the 75th percentile. And one thing we can do with quartiles is use them to measure variability. That's something that's really important in a data set, is looking at its variability. So sometimes a measure of center alone can be misleading. If I only know the median, if I only know the mean or the mode, right, that's not telling us how the data is spread out across its range. So another useful description for the measure of spread, another useful description other than a measure of center, is kind of how spread out the data is. And we can look at the largest and smallest values, right? That'd be like our max and our min, and we definitely will. But like the mean, those are obviously affected by extreme values. So we need to look at those other percentiles, and that's where we're going to calculate our quarters. So to calculate our quarters, what we have to do is arrange our observations from smallest to largest and locate our median, M. And that median divides our data set in half. Our Q1 is going to be the median of the observations located to the left of our big median, M. And our Q3 is the median of the observations located to the right. So let's talk about our 5-number summary. And this gives us a great view of our data set. So our minimum and maximum values tell us quite a bit about our data set, right? We can find our range. And our median and quartiles tell us a little bit about where that data is really concentrated along the range. And to get a quick summary of the center and spread, we take all 5 of these numbers and get a 5-number summary. So our 5-number summary is going to be our minimum, that's our smallest value, our Q1, that's our 25th percentile, our mean, which is our 50th percentile, our Q3, which is our 75th percentile, and our max, which is, of course, like our 100th percentile. But we kind of think of it as a max. And once we have this 5-number summary, it's great. We know these 5 numbers, but that's kind of hard to visualize. And for that, we're going to need a box plot. So a box plot is a graph that displays our data using the 5-number summary. So sometimes it's been called a box and whisker plot. At least it was when I was younger. So what we have is we have our minimum and our maximum. And we have this box with our Q1, Q3, and our median in the middle. And the distance between Q1 and Q3, we call that our interquartile range, or IQR. And that's going to be really helpful for finding outliers. So how do I go about drawing a box plot? It's actually pretty straightforward. So the first thing you need is to draw a number line that spans all the values in a data set. Next, you need to enclose our values from Q1 to Q3 in a box, right? So we've got our min and our max, Q1, Q3, put those in a box. And you always actually want to label them. This is me just making a messy one to show you what's up. And then we draw a line through the box at the median, so that could be our median, our capital M, and we add whiskers to our minimum and maximum. So that's how you make a box plot, but you gotta make sure it's along a number line, right? Otherwise, I don't know what our Q1, Q3, or I really need a number line. So let's look through a worked out example, and then we'll complete an example on our own. So here is a data set of travel times, right? We looked at commuter times for North Carolina earlier. Now we're going to look at these commuter times for New York. And what we're going to do is we're going to find our 5-number summary. So I already know my minimum. I already know my maximum. This data set is 15. Is it 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, this data set is 20. So I've got to find the two middlemost values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be these two. But wait, we have a problem. What did I just do wrong? So we have to arrange our data set from smallest to largest. So if I go ahead and arrange my data set from smallest to largest, right? I've got my minimum, I've got my true maximum, right? That's why it's always important we arrange our data set from smallest to largest. I find my two middlemost values and I take their average to give me my M, my median. And now my data set is divided in half, right? It's divided in half. Let me change colors. It's divided in half right here. So this over here is my lower half, and this over here is my upper half. So my lower and upper half both have 10 values. Again, that's an even number of values. So I have to count 5 in. 1, 2, 3, 4, 5. It's going to be these two. Hint, they were already highlighted for me. And I add those together and divide by 2 to get our Q1. That's what I'm finding, our lower quartile, 25th percentile, which is 13.5. And I do the same thing for our upper quartile. Well, that's nice and easy. It's just going to be 50. So I now know my minimum is 10. My maximum is 25. Let me highlight these so we see them. So my minimum is 10. My maximum is 75. My Q1 is 13.5. My median or 50th percentile or Q2, again, goes by many names, is 32.5. And my Q3 is 50. So we can arrange these on a number line and go ahead and make a box plot. So let's go ahead and take a look at that. So here we have, for New York, this data set we were just looking at, our box plot, and also our North Carolina data set that we looked at earlier in this chapter. As you can see, there's greater variation or variability in New York because it has a wider range, and there's less variation in North Carolina, which we would expect to be true, right? New York has Manhattan. You don't want to drive in Manhattan. Trust me, it's a nightmare. I say that like I've driven in Manhattan. Huh. Okay, so let's go ahead and construct a box plot for ourselves. This time we've been given our 5-number summaries, right? And we kind of want to think about, when looking at this data set, which of the two banks we'd like to be a member of, right? So here we have some data that's the waiting times for banks. So we've got our big bank and our best bank. So let's go ahead and construct a number line. I'm going to make it from 4 to 11 because I think that's my biggest spread. So 4, 5, 6. Now also heads up, you can do this in R, but it's important to know how to do all of these things by hand so we can survive in a world without computers. Okay, so I'm gonna go ahead and do my big bank. Big bank's gonna be in blue, big bank in blue. So I'm gonna mark my minimum, that's 4.1. I'm gonna mark my maximum, which is 11. I'm going to label my lower quartile, which is 5.6. That's my Q1. Again, I'm just making my best to make this appear correct. 8.5, Q3. Okay, so here's our big banks variation, right? So you can have a minimum waiting time of 4 minutes, but then someone did wait 11 minutes. And I can tell you something, waiting in a bank is not fun. So now let's take a look at best bank in green. So my minimum is 6.6. My max is 7.8. Ooh, okay, this is going to be a tight little box. My lower quartile is 6.7. My median is 7.2. My upper quartile is 6.1. Look at this little thing. It barely has any whiskers. Q1 and Q3. So this is our best bank, and this was our big bank. So which bank would you rather be a member of? In my opinion, you pick the one with less variation, more consistency, right? That'd be the best bank, because yeah, at the big bank you could wait a minimum of 4 minutes, but you could also be there 11 minutes, and we're busy, important people. We got things to do. So I'd mentioned earlier that we can find outliers by looking at the interquartile range. So having observed the extremes, our minimum and maximum, those don't describe the spread of the majority of data. And we turn to the difference of the quartiles, right? Because the majority of the data, 50% of the data, is going to be within that interquartile range. It's the distance between Q1 and Q3. So we calculate it by taking Q3 minus Q1. Not the most complicated calculation. But in addition to serving as a measure of our spread, we can use it for a rule of thumb for identifying outliers, which is really like its most useful. So 1.5 times the IQR is our rule for outliers. So we call an observation a suspected outlier if it falls then 1.5 times our interquartile range above the third quartile or below the first quartile. So let's go ahead and calculate those for our New York data set. So in New York travel time, our Q1 was 13.5 and our Q3 is 50. So if we take 50 minus 13.5, we get 36.5. So that's our interquartile range. So if I take 1.5 times my interquartile range, I'm going to get 54.7. So I need to see if I'm 54.7 above Q3 or below Q1. So I'm going to take Q1 minus what we found, which is 54.75, and I get negative 41.25. Well, you can't have a negative commute. Like, you can't gain time back on your commute. So this makes no sense. So we can kind of ignore that one. And then we have to add our interquartile range to Q3 to see if there's any like outliers far above our median. So we take Q3 plus 1.5 times our interquartile range and find 104.75. Well, luckily for us, none of our data set has values that big. So it turns out that this data set has no outliers, right? Because you would have to have a travel time of negative 41.25 minutes. Again, not possible. Or longer than 104.75 minutes. So none of our observations would be suspected as outliers. So none of our New York observations would be outliers, but North Carolina, our data set we looked at earlier, does have an outlier. And that upper wind skirt extends only to the greatest observation smaller than 69.5 minutes. That's our outlier in this North Carolina data set. So as you can see, it's kind of marked with an asterisk, like, hey, here's what our data set would have looked like if we hadn't had to take this outlier into account. And that's why this is a modified box plot.